Welcome back to the deep dive. Today, we're taking a really close look at something quite radical in the anti-aging world, and it's got nothing to do with needles or fancy creams. It's all about the air you breathe indoors. We're diving into what's called the Air Six-Free Doctrine. It's this idea linking air purity directly to, well, your biological age, even your lifespan. So our mission today is to unpack the sources behind this, understand this really strict standard they set, and look at the pretty unconventional tech they propose.
Yeah, and what jumps out immediately is how it shifts the whole paradigm. We usually think of aging as just time ticking by, an expiry date. But this Air Six-Free idea, it throws that out. It says aging is basically a function of how much toxic stuff your body accumulates. And if you even start to entertain that premise, you really have to question everything we thought we knew about clean air inside our homes.
Okay, so a fundamental rethink. Let's get into it. If aging is down to toxins, what kind of environment do we need?
That's where the Air Six-Free standard comes in. It's presented as this absolute benchmark, the necessary state for what they call future human purification spaces. And it means hitting zero, or practically zero, detection for 6 kinds of pollutants, the 6 voids.
6 voids. That sounds intense.
Oh.
And yet, looking at the list, it goes way beyond what most people think of as clean air.
Yeah.
Let's walk through them. Number 1 is dust-free. And they don't just mean the fluff bunnies under the sofa.
Not at all. We're talking virtually zero inhalable particles. Everything from PM 2.5, which we hear about a lot, all the way down through ultrafine particles, PM 0.1, and then into these truly tiny nanoscale things down to PM 0.0001, almost theoretical level.
Okay, so practically nothing particulate. What's next?
Then you get into the bio and chemical side. Void number 2, germ-free. So absolutely no bacteria, viruses, mold spores, any pathogens floating around. Scrubbed clean.
Right. And number 3?
3 is toxin-free. This covers the usual suspects, VOCs, formaldehyde, benzene, xylene, the chemical stuff we worry about off-gassing.
Yeah, but the sources also mention something I don't usually link with air filters, plasticizers.
Exactly, and that's key because plasticizers leak out of so many everyday items, plastics, furnishings. It shows how comprehensive this is.
Okay, what's void 4?
4 is smoke-free. So getting rid of any combustion particles, whether from cooking, tobacco, maybe pollution creeping in, even the invisible smoke residue.
Makes sense. 5.
5 is odor-free. This includes artificial fragrances, pet smells, body odors, even decay gases. They see these as signs of contamination, even if not directly toxic in small amounts.
No smells allowed.
Yeah.
And the last one, number 6.
And this is where it gets really stringent. Heavy metal-free.
Heavy metals.
In the
air.
Things like cadmium, lead, mercury, arsenic, copper, aluminum, whether they're tiny particles or actually vaporized, the goal is to eliminate every single layer of environmental attack.
Wow. That's an incredibly high bar. Truly Six-Free.
It's meant to be the ultimate standard for preserving health if you buy into the toxin premise.
Okay, so if that's the goal, this Air Six-Free state, we need to talk about how we get there. Because the source materials really go after the current gold standard, don't they? HEPA filters.
They absolutely do. A core part of this doctrine is arguing that traditional HEPA filters are, well, fundamentally inadequate for reaching this anti-aging standard, especially for that first void being truly dust-free.
So what's the problem with HEPA, according to them?
They say HEPA is okay, maybe, for preliminary filtering, catching the bigger stuff, PM 2.5 and up, the kind of dust that, eventually settles on your bookshelf anyway. But the core issue they point to is structural. It's the physical mesh itself.
How so?
Well, there's a trade-off. If you make the filter pores tiny enough to block the really small, dangerous stuff, the ultrafines, you basically choke the airflow. Not enough air gets through. But if you make the pores wider to let enough air pass, then the really tiny pollutants, the nanoparticles, just slip right through.
Okay, that makes physical sense. But they put a number on it, didn't they? Something quite shocking about efficiency.
Yeah, and this is a big claim based on third-party observations they cite, and we should stress this needs a much wider scientific validation. But they estimate that standard HEPA filters might only have an overall filtration efficiency of around 20% for the total amount of suspended particles in typical indoor air.
Wait, hang on. 20%? Did I hear that right? 20, not 80 or 90, but 20.
That's the figure presented in the source materials. 20% overall efficiency against everything floating in the air.
If that's even close to accurate, that basically says most air purifiers people buy are barely doing anything against the bulk of airborne particles. That sounds less like a limitation and more like a scandal.
It's a really provocative claim, and it matters hugely because, according to this doctrine, the real danger isn't the big stuff HEPA might catch, it's the ultrafine particles, PM0.1 and smaller. These make up, they say, potentially up to 80% of airborne pollutants by particle count. And unlike bigger dust, these little guys stay floating around almost indefinitely.
Right, they don't just settle out.
Exactly. They're easily inhaled. They're so small. They bypass our body's usual defenses in the nose and throat, get deep into the lungs, and can even cross directly into the bloodstream. This is what they finger for, causing chronic, low-grade systemic inflammation and damage throughout the body.
And HEPA doesn't stop these effectively.
The doctrine's wording is blunt. They call HEPA almost completely ineffective against these critical microtoxins.
Wow. Okay. Now, there was something in the materials that really stood out to me, a kind of practical DIY way. They suggest you can see this failure for yourself.
Ah, yeah, the clean filter paradox observation. That's quite counterintuitive.
Explain that. How does a clean filter mean failure?
Well, the argument goes like this. If you run a standard air purifier with a HEPA filter for, say, 6 months, and the filter still looks pretty clean, maybe just a light layer of gray dust, that isn't proof your air is clean. Instead, they argue, it's evidence that the filter isn't catching the vast majority of particles, the tiny sub-PM 0.3 stuff. Those particles are sailing right through and ending up in your lungs, while the filter only catches the bigger, less harmful bits.
So the visible dirt is almost irrelevant compared to the invisible threat passing through.
Precisely. The filter looking clean is presented as a symptom of its failure against the most dangerous particles.
And the tests they propose.
It's actually pretty simple. They suggest getting a basic, inexpensive sheet of 3M electrostatic filter mesh. You know, the kind you might put over a heating vent.
Yeah.
Manually attach a layer of this mesh right at the air intake of your existing HEPA purifier, before the air even hits the HEPA filter. Then run the purifier as normal. If that simple electrostatic mesh turns visibly dark, brown, or black within just a few days, they say that's your proof. It demonstrates your expensive HEPA filter is letting significant amounts of those ultrafine to nanoscale particles, from PM0.3 down to PM0.0001, straight through, only to be caught by a simple electrostatic charge.
It was a pretty damning and accessible little experiment if it works out that way. Puts the onus back on the user to verify.
It certainly challenges assumptions about what clean looks like on a filter.
Okay, so we've got this environmental failure, HEPA's alleged inability to stop the invisible nanotoxin assault. Let's bridge this back to biology. How does this connect directly to aging?
Right, this is where the doctrine really departs from mainstream thinking. Conventional science generally points to internal factors for aging, right? Things like the Hayflick limit cells can only divide a certain number of times, or telomeres shortening on our chromosomes with each division, or our mitochondria becoming less efficient and producing more damaging free radicals over time. Aging is seen as programmed decline.
Yeah, kind of built-in obsolescence.
Exactly. But the Air Six-Free Doctrine completely flips that. It states, quite emphatically, that cellular aging isn't really about time passing. It's almost purely about toxic burden.
So the constant bombardment from the environment.
Yes. The idea is that when your body is constantly dealing with inhaled pollutants, these ultrafine particles, VOCs, heavy metals, it triggers this chronic, low-level inflammation. And this constant state of alert and repair diverts resources. It accelerates the wear and tear on essential processes like DNA repair, mitochondrial function. Basically, the body's maintenance systems get overwhelmed and burn out faster than they should.
So remove the toxins, remove the accelerated burnout.
That's the core hypothesis of what they term the science of cellular youth. If you can maintain the body in this ultra-low toxin state, an Air Six-Free environment, then cells aren't constantly fighting off external attacks. They can maintain their function, their structure, their youthful integrity for much, much longer.
And this could actually delay or even reverse visible signs of aging, like wrinkles, skin pigmentation.
That's the claim. They connect it very directly to skin because it's our most visible organ, the interface with the environment. They even propose this stark equation. Your degree of facial aging equals your level of internal toxin accumulation, which reflects your overall health, and that ultimately indicates your lifespan potential.
So looking older isn't just about birthdays. It's a direct readout of accumulated toxic damage.
According to this doctrine, yes. And they get specific about skin damage mechanisms. It's not just surface dirt. They talk about how these ultrafine particles, VOCs, chemical residues from the air, can actually penetrate through the skin layers into the dermis, causing damage from within.
Huh. And they also mention something about cleaning habits.
Yeah, kind of an interesting side point. They note that we tend to clean our faces much more diligently than, say, our necks. And areas with fewer oil glands, like the neck, lack that natural protective sebum barrier, making them even more vulnerable to airborne chemical and particulate penetration. It all ties back to minimizing that environmental insult.
It's a complete picture of environmental factors driving biological decay, from the air we breathe to the particles landing on our skin.
Exactly. It frames aging primarily as an environmental problem, not a purely genetic or time-based one.
Okay, so the problem identified is these invisible, often negatively charged nanoparticles that allegedly slip past HEPA. What's the proposed solution? What technology achieves this Air Six-Free standard?
This leads us to the specific device mentioned in the source materials, the Air Six-Free Maze Purifier.
The Maze Purifier. And the key claim is it can filter these tiny particles down to PM.0001.
Yes, that's the assertion. It's designed specifically to tackle the particulates and aerosols that physical filters like HEPA struggle with. And it does this by using a combination of methods.
Not just trying to block things physically.
Right. It uses a dual-layer approach. There's a preliminary physical filtration stage, likely for larger stuff, but the core seems to be a powerful electrostatic mechanism.
Okay, electrostatic. How does that work on particles too small to see, let alone block?
Well, it leverages the physics of the pollutants. As we mentioned, many of these airborne ultrafine particles naturally carry a slight negative electric charge. The Maze Purifier apparently incorporates a step called secondary ionization. You can think of it as ensuring all particles become targets. This stage does things like neutralizing pathogens, but crucially, it imparts a strong negative charge onto any remaining particles, regardless of size. Everything gets magnetized negatively.
So you're actively charging the pollution itself, making it controllable electrically.
Exactly. You're using its own potential vulnerability against it. Then, these newly negatively charged particles are forced into what they call the electrostatic collection maze box.
The sacrificial black box, they also called it. Sounds ominous.
A bit, yeah. But the principle is straightforward. This maze has internal surfaces that are maintained with a strong positive charge.
Negative particles meet positive walls.
And sap. Electrostatic attraction forces them to collide with and stick to the positively charged surfaces. They're pulled out of the airflow and trapped prominently adsorbed.
And the maze part. Is that just about the charge?
There's another layer. The airflow itself is apparently forced through a complex path with repeated sharp turns inside this box. This maze effect dramatically increases the chances that even the tiniest nanotoxins carried along by the air will physically collide with the charged collection surfaces rather than just flowing past. It maximizes the collision probability.
Okay, so it's ionization to charge everything negatively, then attraction to positive surfaces within a tortuous path to ensure capture. It's quite an elegant physics-based approach.
If it works as described, it addresses the core issue of capturing particles too small for physical filtration.
The technology sounds clever, definitely a different approach. But the tech is only half of this. Let's talk about the prediction that comes out of this doctrine. Because this is where things go from radical to, well, almost science fiction.
This is certainly the part that's generated the most buzz and the most skepticism.
We're talking about lifespans of 300 to 500 years. Let's be really clear. Are the source materials suggesting this is guaranteed if you use the purifier? Or is it more theoretical? Does the model account for, accidents, getting hit by a bus?
That's a crucial distinction. No, it's not predicting immunity from accidents or acute disease. This prediction comes from an AI model interpretation. The model is based on the premise of achieving near-perfect environmental protection, the Air Six-Free state. It simulates what happens to cellular aging under those conditions.
And the simulation shows.
It predicts that in such an environment, with minimal oxidative stress and chronic inflammation, cells would experience virtually no premature aging. They'd maintain their integrity far longer. So the radical claim that a 60-year-old could look and function like a 25-year-old is an extrapolation from that idea of sustained cellular youth.
Okay, but the 300 to 500 years, where does that number come from?
That figure represents a theoretical biological ceiling for human lifespan, purely defined by removing the environmental toxic burden as a primary driver of aging. It's what the AI model suggests could be possible if cellular damage from external toxins is essentially eliminated. But, and this is critical, the sources themselves state this is an AI simulation hypothesis. It cannot yet be verified through current experimental methods. It's a projection based on ideal conditions.
But they also added, cannot be disproven yet either.
Right. It sits in that space of theoretical possibility based on their core premise. Aging equals toxic burden. If you remove the burden, what's the limit? The AI says maybe 300 to 500 years. It's defining the potential if the environmental decay factor is nullified.
So a massive if, but one based on their central argument.
Yeah.
Okay, let's wrap this up. What's the big takeaway for you, the listener, trying to make sense of all this? For me, the core shift is moving the focus. It's saying, forget just filtering the dust you can see. The real battle is against the invisible swarm, the electrically charged nanopollutants that supposedly make up 80% of airborne toxins and slip through standard defenses.
Exactly. It forces a hard look at the connection between our immediate environment and our fundamental biology. It challenges us to think beyond chronological age, beyond just our genes, and seriously consider environmental toxicity, particularly air quality at this nano level, as maybe the primary and potentially manageable driver of how quickly our bodies break down. Control the environment, control the decay rate. That's the message.
And that projection model, the 300, 500-year lifespan, even as a theoretical AI simulation, it's clearly done more than spark scientific debate. The sources mention intense public interest, especially among younger people looking for radical health solutions, but also, interestingly, quite emotional reactions from women over 30, who perhaps feel the pressures of visible aging more acutely. So here's the final thought to leave you with. What happens if this concept, even partially, proves true? What are the profound psychological, social, economic implications if preserving youth stops being primarily about luck, genetics, or time, and becomes, at least in theory, an environmental engineering problem, something you could potentially buy, maintain, achieve through technology? If aging is solvable by cleaning the air, what does that do to us? That changes, well, potentially everything.